implementing feature extraction.
In this section, we are going to take a look at feature extraction, dealing with categorical data, and then merging and expanding numerical data types. Let's first look at feature extraction. In this video, we are going to check model performance after applying principal component analysis, which is a method of feature extraction on our German credit dataset. Okay, let's load our Jupyter notebook again. And here we're going to import some packages that are going to help us build a model and then also run our feature extraction method. So over here, we're importing PCA, which stands for Principal Components Analysis, from scikit-learn. So let's load the data again. This is our German credit data set. Now let's talk a little about feature extraction. Feature extraction is the process of dimensionality reduction. Principal component analysis is a very popular method for feature extraction. It helps reduce dimensions by creating a new set of variables that are smaller than the original set without losing any information. This is done by obtaining orthogonal linear combinations of the original variables. PCA is typically used on very high dimensional data. Our data set does not have a lot of dimensions, but since this is an introduction course, we're going to still use PCA on this data set and then see what impact it has on the model. So one point about PCA is that it does not improve the performance of random forests, because random forest already checks feature importance and builds a model based on the important features. That is because decision trees are always looking at entropy, and that's how they decide what weights to give to each of the parameters. So instead, we're going to run a logistic regression model on the same data set without changing any parameters. And then we're going to run another logistic regression model on the data after we have reduced the number of dimensions using PCA. Just like we did before, we are going to create our input variables and our output variables, and then split the data into training and test set. Now let's run a really quick and dirty logistic regression model. The accuracy of this logistic regression model is 0.75, which is not great. Okay, now let's try to run PCA on the raw data and reduce the number of dimensions. First, we have to scale our data set. Scaling it standardizes the data set. This is important because we have variables like age and then also our categorical variables. So age will go up to 70 years, whereas the categorical variables will be 0, 1, 2, and 3. This kind of confuses the model a little bit because it will assume that higher numbers mean more information. So we need to scale all the numbers down to a number between 0 and 1. So we need to scale all the numbers down. We're going to check our covariance matrix so that we can calculate the variance ratios and so that we can see how much of the variance is explained by how many features. So usually what happens is that at some point, this will be flattened out. That means beyond a certain number of features, there's not much more information that we are gaining about our output variable. But as we see over here, we don't have that flat line. And that's because our features do provide a lot of information. But just for the sake of this example, let's pick the number of components equal to 13. And then let's assume that some of the original features were also good. And we will select one feature out of that. Now, let's build a combined feature between the PCA features and our one K-best, the one feature that explains the most as our selected feature. So in total, we have 14 features. Again, let's split the data into train and test set, and let's fit the logistic regression model. As we can see now, the accuracy of this model is 0.8. So what this means is that even though we have worked with a data set with not a lot of features, and we also didn't have complete clarity on how many features provide the most number of information, just by choosing the features, the top 14 features that provided the most information, and removing the other 6 features, we were able to gain much more important information and get rid of some of the noise, which led to this accuracy increase. To summarize, in this video, we have looked at feature extraction. We have used a method called principal component analysis to pick the best features and extract them. And then we have compared model performance of logistic regression on data that did not use PCA and data that did use PCA, and we compared these two models.